Welcome to myprojectbazaar.com. Automatic itinerary planning for traveling services. Creating an efficient and economic trip plan is the most annoying job for backpack traveler. Although the travel agency can provide some predefined itineraries, they are not tailored for each specific customer. Previous efforts address the problem by providing an automatic itinerary planning service which organizes the points of interest into customer itinerary. Because the search space for all possible itineraries is too costly to fully explore, to simplify the complexity, most work assume that user trip is limited to some important point of interest and will complete within one day. To address the problem limitation, in this paper we propose a more general itinerary planning service which generates the multiple itinerary for the users. In our service, all point of interest are considered and ranked based on user preference. The problem of searching the optimal itinerary is team orienting problem, well-known NP complete problem. To reduce the processing cost, the two-stage planning scheme is proposed. In such algorithm is used to combine the single day itinerary. In this way, we transfer top problem with no polynomial approximation into another complete problem with good approximate algorithms. Creating an efficient and economic trip plan is the most annoying job for backpack traveler. Although travel agency can provide some predefined itineraries, they are not tailored for each specific customer. Previous efforts address the problem by providing automatic itinerary service which organize the point of interest into customized itinerary. Because the search space of all possible itineraries is too costly to fully explore. To simplify the complexity, most work assume that user trip is limited to some important point of interest and will complete within one day. The automatic itinerary planning service need to return an itinerary with highest ranking. Searching the optimal itinerary can be transformed into team orienting problem, which is the NP complete problem without polynomial approximation. The travel agency provide efficient and convenient service for experienced travelers. The itineraries provided by travel agents lack customization and cannot satisfy the individual requirements. Some point of interest are missing in the itineraries and the packages are too expensive for backpack traveler. Therefore, we have to plan the trips in every detail, such as selecting the hotels, picking point of interest for visiting, and contacting the car rental service. To attract more customers, the travel agency should allow the users to customize their itineraries and still enjoy the same service as predefined itineraries. The traveling market is divided into two parts. The casual customers, they will pick a package from local travel agents. The package in fact represents the pre-generated itinerary. The agency will help the customer book the hotels, arrange the transportations, and pre-order the tickets of museums, parks. It prevents the customers from constructing their personalized itineraries, which is very time consuming and inefficient. In our process, a novel itinerary planning approach is proposed. The design and philosophy of our approach is generate itineraries that narrow the gap between agents and travelers. We reduce the overhead of constructing personalized itinerary for traveler. We provide the tool for agents to customize their service. The point of interest are organized into undirected graph. The distance of two point of interest is evaluated by Google Map API. Different ranking functions are applied to different type of point of interest. The automatic itinerary planning service need to return itinerary with highest ranking. Searching the optimal itinerary can be transformed into team orienting problem. The first step is data selection. In this step, the location data is selected and applied to pre-processing. In pre-processing step, the garbage value should be removed from the data set, and then we find out the Euclidean distance between the location objects. Then we have to find out the cluster community for different itineraries using LDA clustering and produce the end itinerary. Let me see the demo of automatic itinerary planning for traveling service. First of all, we select the home.java. In this frame, we select the location dataset. Data loaded successfully. This is the location dataset. This is the location. This is latitude and longitude. After select the data, the pre-processing is performed. In this process, the garbage value should be removed from the dataset and loaded into the relational database. Get the user point of interest in this frame. Select the user point of interest. Next, select the user current location. This is the latitude and longitude of user location coordinate. Then we have to find out the Euclidean distance between user location and other locations. This is the distance between user location and the user point of interest location. This is the cost for the distance. This is the sequential probability tree for user location and the user point of interest location. Then we have to enter the number of itinerary and estimate the cost. This is the number of itinerary is 5. The first itinerary is estimated cost is 1000, and this is the total cost for itinerary 1. This is the itinerary 2. In itinerary 2, estimated cost is 1000. This is the location. The estimated the total cost is 846. In itinerary 6, the estimated cost is 1000. We produce the number of location is Fairhope, and the total cost for itinerary 3 is. Next we go to itinerary 4. The estimated cost is 1000. The itinerary location is District 7 and Louis City. The distance is 978 and 981. The total cost for itinerary 4 is 978. Then we go to itinerary 5. The estimated cost is 1000. There is no location for itinerary 5. Thank you.